pressure gauge is the C-shaped Borden tube. The key parts include a bezel ring that holds the window onto the case, a window that is typically 3 mm safety glass, an inner ring that keeps the window away from the pointer, a pointer that rotates with pressure, and a stop to hold the pointer at a set unit. The dial is used to display the units of pressure and is typically white anodized aluminium. The gauge case and rear cover protect the inner parts of the pressure gauge. The key parts within a Borden tube pressure gauge include the movement, which includes the hairspring, gears, and linkages, a C-shaped Borden tube which is typically bent at an angle of 270 degrees and has a closed end, a linkage which can be adjusted when calibrating, a quadrant-toothed segment which attaches to the movement, the connection which can be either direct, flush, or surface mounted. As the media enters the bottom, it moves up through the connection and socket and enters the Borden tube. With increased pressure, the tube expands and tries to straighten out, resulting in the movement of the linkage, quadrant, and gears. As the quadrant moves, it turns the gears, contracting the hairspring. The end result is the rotation of the pointer, which displays the corresponding pressure units on the dial. There are 3 types of Borden tube. The C-type, which is the most common and tends to be used for lower pressure applications. The spiral shape, which is used for medium pressure applications. And finally, the helical type shape, which is used for very high pressure applications. The advantages of using a Borden tube are simple mechanical analog construction, no need for a power source, inexpensive compared to a digital pressure gauge, accurate results as long as it's calibrated periodically. It can also be used for measuring a vacuum. A wide range of specifications are available. Borden tubes have a long life expectancy if maintained properly. The disadvantages of a Borden pressure gauge are hysteresis can cause inaccurate readings. Pulsations and vibrations may damage the gauge. Readings are slow to respond compared to digital pressure gauges. An amplification mechanism is required to increase the free end of the movement. The benefits of using a Budenberg pressure gauge are optional anti-vibration viscous damped movement,